with the stuff that I've done this year. Um, so I'm a little, I've been thinking about it a lot. Whereas, you get fresh stuff out of some of these other people, like the way it was when I was talking to Walt Boynton. It was just, you could see the enthusiasm on his face and his expression when he was telling the way he kind of connected with HT. And So I know that there's going to be some enthusiasm from the students, and um, you know this from your own personal experience, but how far the influence goes, and to me, one of the things that really got me going this year was that I thought HT's been forgotten, and so his influence, um, and so I was pretty worked up at the beginning of the year, but then having participated with Charlie on this dialogue that we've had all year round about maximum power principle, it's been pretty good, and there are some people that are trying to figure out the maximum power principle. So I think that's good. Um,
Yeah, I think the maximum power principle, that's something that seems like it arises in different forms and different segments of science at different times as well, under different kind of names. There's this one idea of assembly theory. Have you heard about this? I just found out about it the other day. It comes
oh,
from like organic chemistry. It's basically an emergy concept, but they're thinking that if you can track all the number of steps it takes to assemble organic compounds all the way up through, humans and organisms, that's a measure of
oh,
there's a principle there, and I think there's a lot of correlations between that and transformity, and the idea that there's this historical record that it takes to make something, but they completely think of it in a different currency because they're thinking of it like the number of bonds that you have to create.
well,
Um,
that's the thing, is that if we think of the maximum power principle as sort of a law of thermodynamics, I mean that's a pretty big deal, and but it should be something that we all should be able to understand and agree upon. But I think there's a lot of different people thinking about it in different ways, like you just said, and there isn't, it hasn't come together the way the true laws of thermodynamics came together, and you know um stood by never being disproved. um
yeah,
and so it might be just the nature of the times, where we just have so many people doing so many different kinds of things, that ideas don't gel the way they did, like in the 1800s, when there weren't that many people actually studying things. But I don't know. I think it would be interesting. I mean, I think that's an interesting thing, is this, to me, if you had to say one thing that HT really did, I mean, I would say, I, I, I think I would say it was the maximum power principle. I mean, that's what impressed me. It was like he came up with this as a law, that would be equivalent with the first or second laws, and that's a pretty big deal. And the thing that interests me is that it doesn't just apply to ecosystems, which is where it arose. It applies to physical systems too. So in other words, it works everywhere in the universe. And so, geez, we ought to understand this, but we really don't. And in the conventional thing, they're into this complexity theory, which I think is, off on wrong path, But anyways,
Hey, Pat.
hey, Mark, this is
Sorry,
like the first time ever on Zoom.
really?
Yeah, I've religiously tried to, stay
Stay
off.
away from.
I was only on it one other time, when I just came in when somebody else was doing it. So I hope that, like, I'm not going to be manipulated by AI, and I'm gonna end up being some kind of cyber criminal, because the AI has manipulated what they're getting out of me from this. But I trust you two.
Yeah, it's okay.
you can trust us, but you can't trust the internet and society too
Yeah,
much. So
yeah,
we'll do our best.
yeah.
Uh, I hope you don't mind. I hit recording. You're saying such great, phenomenal things. I just went ahead and hit the record button, Pat. So we've got that.
Oh, well, I was Mark, I was saying I'm not sure I'm the best guinea pig because I've been really, as you know, I mean, I've been really trying to come to an understanding in my own mind about HT's legacy, especially over this year. First with the talk I gave at the Emergency Society in January, and then a little bit more at the one at the AES meeting. I mean, and then I've hooked up with Charlie Hall on his exchanges. He's got a following through this biophysical
Yeah.
economics institute, and they are Charlie and another guy who apparently is a philosophy professor at Montgomery Community College, just down the road from Dave and I, are writing a book on maximum power.
Ah, cool.
And yeah, I mean, and so I kind of got hooked up with them dialoguing about it and seeing how our different ideas about maximum power contrast and come together. And so I'm not the good guinea pig, just in that I've been thinking about HT's legacy, and now I'm writing this letters book.
Yeah.
And I've just finished 140 letters, typing up these letters between HT and EP. So I mean, I've been thinking about this quite a bit. I may not be the best one about being spontaneous or anything, but anyways, I'm happy to be a guinea pig here.
Great. Well,
Been
we're
thinking. Go ahead,
thrilled.
Mark.
I said we're thrilled that you want to take part, and this is such a cool idea that trying to get all of this recorded and
Yes.
hopefully put away so that it's available. But I don't trust, as HT, I don't trust the digital world to keep anything. I
You got
had
to
all
keep it.
this data, and all that data was on Bernoulli disks, and there's no such thing as a Bernoulli disk or a disk drive. So
Well,
half of my life is gone.
one of the interesting things is that I think that that the study that HT and EP did in 1954 on Anahuac, where they wrote what amounted to what I think is the classic ecological energetics paper. It was the first one. Now there's some interesting antecedents with Lindemann and Jude, and but I mean they put everything together, and so I dug around in the University of Georgia library where EP has his collection, and there are the original notes,
Oh,
and they're in
really?
HT's handwriting mostly, of the data that they took there on, they had 5 quadrats, I think it was like 4 by 4 meter quadrats, and they sampled everything in there, and it's all in handwritten notes in the library. So I mean, you think about digital storages, the libraries still work, but of course, when you come up with some dystopian, futures, maybe the University of Georgia library will burn down and all that stuff will be gone. But I mean, for right now, it's such a treat to go in there and see the actual handwritten notes from the
Yeah,
Anahuac study that
that's really cool.
where I think it all started. That was, it got published. HT was doing the Silver Springs study while they had this chance to go out there, and so they actually pulled it all together with the Anahuac study before HT did Silver Springs. So it's really it's the first ecological energetics, and to me it's really this it's at least one place you could say systems ecology started, in the sense that a whole system was actually studied.
Yeah.
Lindemann didn't actually, he did a lot of hand waving because he was doing it all by himself actually with his wife, and on this little bog lake. But I mean, HT and EP really put it together, I think, on Anahuac. And you
Cool.
can see that the rich notes in the library still.
We got to get all that together someday too.
So I've been reading your radio ecology textbook, Pat, and I didn't finish it, but I saw, your kind of thesis, that what you just said, that Odum and his brother really got systems ecology started, and that kind of thinking at that time with the Eniwetok study. I was wondering if maybe you could say a little bit more about kind of that study in particular. What, you really traced that pretty heavily.
Well, the thing of it was it's funny to think about this because it was all because of the atomic bomb. That society put so much money into funding research on the bomb, and because of course it was to try to stop World War II, end World War II, and then of course once they had the bomb, and this this is the Oppenheimer movie, they couldn't stop. It's like a technology that becomes autonomous. So there was no way they could say, "Okay, we're not going to build the bomb because Germany has been defeated." They kept going, and that's a very interesting story of how technologies become autonomous, and out of they have a life of their own. That's sort of another story. But anyways, um, they 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 raced along with the bomb technology, and of course we entered the Cold War. It was only after about 5 years that the Atomic Energy Commission realized it was actually it's an interesting story. It's when they blew up a bomb that was too big. They didn't know it was going to be that big, and then the radioactivity spewed onto a whole bunch of people that were out in the Pacific Islands, and that was the trigger to realize that they had to fund environmental work, ecology. And so they were the largest funder. They pumped millions of dollars into ecological research, and that's where ecosystem science started. It was because of all of that money. And if it hadn't been for all that money, we were in ecology, we were sort of just putzing along with, little, nice ecological theories about, birds and protozoans, and it was fun
Right.
stuff, but it was all that money in a short period of time where they wanted to understand, was this going to destroy everything, and so it was good that they funded that much. And it's a great story because they funded ecosystem research in all the major biomes. And the one that the little story about the Odums and Eniwetok is just a footnote to the whole story of all of the money and the projects that went on in this fascinating work that showed how ecosystems react to the atomic radiation and the atomic bomb. And um, there were full-blown ecosystem studies in the temperate deciduous forest at Oak Ridge and at Brookhaven. And in actually there were little studies done all over. That it's amazing how much freedom they were given to dump radionuclides in ecosystems all over the place, which I don't think that we would do today. But it
Well,
just goes to show
didn't
that
they
they were
fund
so
the
worried about what this new technology was going to do to humanity that they put a lot of money into it. And I think that's what gave the boost to systems ecology, to the ecosystem concept.
didn't they give the funds to do the rainforest project?
Yes, they
Yeah.
did. And there were big projects in Alaska, in the Arctic, and all of this was done by the US. The world didn't start really studying radiation and ecosystems until much later. So the US was the leader. And one of the interesting things was, and this is a side note, but what were they doing, in Russia and the Soviet Union? They had their own approach to ecology, which was very different than ours. They had an ecosystem concept, but it wasn't really functional in the way that ours turned out to be. So we really invented, studying energy flow and tracking food webs and nutrient cycles, of course, importantly, because of the atomic
Yeah,
energy and the radiation that was getting spewed all around.
they were trying to follow it through the ecosystem.
Yeah, and that's where they understood, they really, it forced you to really understand nutrient cycling by seeing that. And so there's just one fascinating case study after another, and I tried to do the main ones in this book, but there's a whole bunch of little ones too that I think were interesting. you could, even if you're a high school teacher, you could get nuclides from AEC and dump them in a pond in your on your college campus. I mean, it's amazing what they were able to do, and it's just a fascinating story. And one of the interesting things is how they couldn't you couldn't really destroy an ecosystem. I mean, they'd always come back and they'd self-organize, and they found some species that would resist it. And so there's a lot of interesting stories about self-organization in there that are forgotten, and that
Yeah.
was one of the reasons why I wanted to write that book.
I remember talking to Dr. Odum about that when I was at Florida, and he posed the question, I think to class or maybe to system seminar, and talking about how they had exposed all these different ecosystems, a temperate one, like the one in South Carolina, and then the one in Puerto Rico, and then one other ones. And he's like, which ones do you guys think recovered the fastest? And we're like, scratched our head. And he's like, well, it's the one in the tropics, had all the diversity and had the productivity. So
Yeah,
he
they
knew.
the thing was that all the experiments were different, and you couldn't really compare them. I mean, the thing they did at Alverde, which I know pretty well. I spent some time down there, and I remember where the site was. You walk by it on the trail every day. I was there in the '80s after it was, in the '60s that they did it, but it was only out for like 3 months. And so, whereas like at the radiation source, but at Brookhaven in New York, they left it there for 15 years, and so there were all kinds of experiments. And of course, out in Nevada at the Nevada test site, they were blowing bombs off and watching what happened to ecosystems. So there were all different kinds of experiments, and it's just a fascinating story. I think that is part of the history of ecology that I think is good for us to know about.
So I knew this podcast was a good idea to start with Pat, because Pat's been talking this entire time. This is exactly what we
Yeah,
wanted.
yeah, that's
So,
Unprompted. This is
yeah.
great.
So let's back up and just, you worked with HT. When did you arrive in Gainesville and how did you get there? And what were your first impressions, that kind of stuff?
well, I first got in touch with HT through Environment, Power, and Society, which I ended up getting a copy of. And right as soon as it came out, and I was an undergraduate at Kent State University in Ohio, and I remember reading it then. And my real ecology was based on E.P. Odom's Fundamentals of Ecology, the third edition, which I knew backwards and forwards. And but his came out, they both came out at the same year, 1971. And so I really read both of the Odom's books. And then in my undergraduate work, I worked with one of the guys who had worked with EP on ecosystem metabolism in microcosms, and I think that was important. I think not too many people really appreciate ecosystem metabolism, if they haven't measured it. And but I had the good fortune of doing some actual measurements in microcosms, which were relatively easy to do as an undergraduate. Then I went to Oklahoma and for my master's, and I ran into Martha Gilliland, who had just graduated from
Oh,
Gainesville as an Odum student, and she had just come to Oklahoma, and I really connected with her. She had a research position in the College of Engineering there, and she ended up being on my master's committee. And she's really the one that got me into Gainesville. I would never have been able to get. I don't. Although Odum he would take anybody really.
oh yeah.
In my experience. So, but I always think that there was no way he would have taken me as a student if Martha hadn't recommended me. I think, and so I got into Gainesville from Oklahoma. And the interesting thing is, I my major professor at Oklahoma really got into Odom stuff too, and he got me and my lab partner to go to the famous 1974 energy workshop. And that was, to me, that was just blew my mind. So I went to Gainesville for about a week. I got we got a tour of the Cypress Project by Bill Mitch, long hair, beard. And Mark Brown had hair down to his shoulders and a big beard. And him and Costanza were teaching. They were, these guys were like 20, 3 years old, and they were ended up teaching classes on the energy systems language and the modeling of it in 1974. I remember seeing Mark, who at the time I thought, God, this guy is really big shot. Walking down the hill towards the Center for Wetlands, and he's got this big beard. Him and Costanza are talking because we just been up at the forestry building where they had this little workshop on the energy systems language, and I thought, God, this guy is like, he really knows what he's doing. He ends up being like 23. He's a couple of years older than me. And I've always wondered how Mark got to, be on the fast track with Odum. But anyways, I really got hooked with that 1974 workshop, which just blew my mind. I remember we had a big lecture towards the end on Odum was talking about the maximum power principle, and I was just amazed by it, and thought it really explained everything. So then I was lucky enough to come to Gainesville, and after I finished my master's, actually before I finished my master's in 76. So I started in 76 and was there from 76 to 79. And then I left for a teaching position, but I didn't actually graduate till 83. So sort of
really, I didn't remember that.
Yeah. So
So what was it like when you got to Gainesville and started taking classes with Odum in this like 76? Like, what was going on then?
I was deadly afraid of him the whole time, basically. I mean, I was in terror. I had said some wrong things to him, and I was sort of into this traditional community ecology theory and done for my master's thesis, and I was talking to him about it, and he thought that was just crap, and he really laid into me one day down into his office. And then there were a couple other times I was really afraid of him. We always used to have to get him to sign off on our classes, and I remember, I didn't always do that, and you're worried he's going to catch you, and one time I came up with I wanted to do my PhD because I was really excited about applying these ideas that came from ecosystems to human systems. So I wanted to do a little community. I wanted to do Cedar Key. I wanted to do the energy analysis of Cedar Key. And I went in there and told him that. He said, "What are you crazy? Walt Boyne just did this. Why do you want to do that?" Because he had done the Apalachicola and the little coastal community there. And so then it turns out, like 3 years later, one of my classmates ended up doing Cedar Key for his master's thesis. But he said, "Why do you want to do that? I mean, that's already been done." So I was constantly in fear of him, as on a personal basis, but intellectually, it was amazing to sit in on the classes and the seminars, and I was there at a really fun time, I think, because it was right at the transition between the switch from analog computers to digital. So when I took systems ecology, the class, we had to learn the analogs. We had to simulate our class project on an analog computer, which I just thought was fantastic. But then I remember in 1977, he bought these, the little bent laptop or the tabletop computer, just brought it in and just left it in the center, and just, he knew we would play around with it, and we did. The students were just playing around with it. But that was right at that transition, and so I was taught on the analog, and I really am so glad that I did that, because I don't think anybody can imagine what it's like to simulate an analog computer without actually doing it. It was so different than simulating on a digital computer. So I got the benefits of both of those worlds.
It was pretty frustrating. I remember that a potentiometer would go down.
Yeah,
You didn't know it was down, and your whole model wouldn't work, and it would take you hours before oh wow, that pot is bad. not pot. That potentiometer is bad. Oh, it was frustrating.
What were those first digital models like, though, on the computer? Like, what kind of programming language and like the symbology? I mean, all that stuff was pretty translatable even at that point for you guys,
well,
or?
we did, we had like this one guy, John Alexander, who was a real interesting fellow. He was a faculty member, I think, somewhere, but he ended up coming to getting his PhD with, I mean,
Yeah, he was in urban and
at the
regional planning.
university. Came and got his PhD with HT, but he was into Dynamo, and so at the time, this sort of Forster language, we liked that a lot. But I mean, it was easy just to do, in BASIC is what I ended up doing my actual PhD model in was in BASIC with difference equations, and but we all had to live in Fortran. I never used it, but I thought that Dynamo was exciting at the time, but it was just BASIC, and then I learned it. It was so simple and easy to do. I ended up teaching systems ecology for a decade after I left there, just with those same things that I learned
Yeah.
there. And later I tried to find an analog computer just for the fun of it, and I couldn't. I've never been able to find one of those Miniacs that we used to have.
They're gone. They're scrap.
Yeah.
I thought
So
you were working with,
what was the title of your dissertation?
It was something about like energy analysis of landscapes. But yeah, and so I did sort of a general systems theory of geomorphology, but also the main focus was on the phosphate industry. I
Right.
was one of the first ones to get into that world of phosphate reclamation, and which ended up, as Mark well knows, a huge part of the Center for Wetlands work. I mean, a lot of work got done there, a tremendous amount of research. I think it'd be fun to write a book on that, synthesize all the stuff that was done by you guys, most of it by Mark and his students later on reclamation of the phosphate lands. I started out on the terrestrial side. Most of the stuff that came afterwards was on the wetland side. But there were just these great these great landscapes there. I mean, I liked it because I wanted to be in I didn't want to be in nature. I wanted to be in something that was really wild. And these phosphate landscapes are wild. They huge areas of strip mining, and then with wonderful little wetlands mixed in. Whole creeks and streams are obliterated, and these big clay settling ponds. I mean, so a whole bunch of people ended up doing their work there. A lot of money came from that phosphate industry that I think was a very enlightened connection between Odum's group and an industry. I don't know, Mark certainly knows this, how much impact that really had on the phosphate industry itself.
Huge. It was huge.
So much research was done. That's why I think a book should be written on that. I think it'd be a brilliant book. I don't even know, a tenth of the stuff that happened after I left. But I know that it's tremendous amount of research was done there. And I think that was something that doesn't often get, associated with Odum. I mean, I wonder how much his thinking through Mark and others, ended up helping the landscapes of Florida because of reclamation.
It was all systems ecology.
Yeah, right.
how did HT get involved? I mean, the industry approached him, or do you know how that kind of worked out?
I think
Or
it was
Mark, were you the
through
lead on that, or?
I think it was through me, actually.
Hmm.
I think I was the one. I made the contact with those guys, and then I remember one time driving down there with Odum to talk to them, like in '78 or something like that. And so I think that I was the first one to get the money from them. Although Martha, of course, Gilliland did her thesis on the geochemistry of phosphate, and she was, so she might have been the first one, really. But in the starting in the late '70s, and then Mark knows better than me, a huge amount of research was done. I think and I've always enjoyed it. I remember Betty Rushton's, it was thesis on the clay succession in the clay ponds, and there were these really neat willow forests covered with vines, and there was so much self-organization going on there. I just thought it was so much fun to be driving around those landscapes. I loved it down there. in
Yeah.
Central. I did my work in Central Florida. There's another phosphate district in North Florida, but I never got up there. And I don't know if you guys ever did anything in the North Florida stuff or not.
Yeah, we did. We had a couple projects up there. So I think the money came from a severance tax on phosphate, and they formed the Florida Institute of Phosphate Research to use that money. And in theory, it was supposed to be money that would benefit the industry. You know, I mean, research that would benefit the industry. And of course, most of the engineer types and bureaucrats thought it would be stuff that would, you know, make phosphate mining more efficient and, you know, better facilities, whatnot. But there was a little thing in there that during that same time, the legislature, because of the governor, had put together requirement to reclaim, and no one knew how to reclaim. They were just smoothing it out. And so the Florida Institute of Phosphate Research became really big on reclamation, and Odum saw cha-ching, he saw a lot of money there. And so he started writing proposals, and then I started writing proposals. And I mean, it funded the Center for Wetlands for almost 20 years, a significant amount of money and a lot of research, a lot of graduate students. So it was a fantastic thing.
Don't you think it'd be fun to sort of synthesize that and do like a little book, you know, on
Sure.
all of the guys that I mean, there were lots of fun things. Like I remember that one guy, one student who was the brilliant coral reef ecologist in Kenya. He did a little study of birds perching on the trees and how they were dispersing the seed. But the thing of it is that they didn't really understand it. My one of my big things that was controversial was that because they did that strip mining, they created landforms where there weren't any landforms. And to knock them down was, in my mind, was the wrong thing to do, because you had already embodied energy in this beautiful landscape. And I think in the terrestrial side, at least, there were species that took advantage of that. And so what did they do? They ended up knocking the spoil mounds down, and they lost all that energy that they had inadvertently, as a byproduct of the mining, put in there. And so to me, that was the wrong way to restore this landscape. But of course, that was not,
No.
no, that was not what they wanted to hear. That, no.
You're lucky you graduated.
I know.
I'm joking.
These are great. So what was it? So did you get to visit the sites with Odum? Like you guys were walking around the sites, and he
Well,
was
I
there
used
helping
to,
sampling and stuff like that, but
no,
yeah.
he came down there with me one time when we went and we met with the, you know, these mid-level muckety bucks, you know, in the phosphate institute that Mark was talking about, and the guy who was my contact. But no, well, then we just drove back. It was like a 2.5 hour drive to Lakeland from Gainesville. But I used to do it all the time. I would get up in the morning and drive down there and do all my field work and come back at night. And so I went down there a lot. And there were so many back roads, and you know, there were all this big machinery. And I mean, it was a very exciting place, you know, lots of energy, and beautiful landforms. And you could find pockets of old vegetation that had come back on some of the first spoil mounds. And that's what I did, looking at succession of different age spoil mounds. And that's how I figured out how the succession was working on the terrestrial side, and why I thought it was a bad idea to and it was a bad idea to knock those things down from an energy point of view. But I mean, if you look at the bigger society, they weren't able to handle the notion that, you know, that there would be topography in Florida, so it had to be flat. So they knocked down and planted pine trees, you know, whereas there were these beautiful hardwood hammocks that were growing in these nice little notches, and there were weedy species that would colonize the erosion rills on the spoil mounds and cover it all with soil organic matter and stuff. So I mean, so yeah, my ideas were not were not popular with reclamation industry.
Probably not the first time I've heard somebody related to Odum or Odum's ideas not being popular. I think there's probably some other examples. I was thinking like of the nuclear power plant.
Oh yeah, that to me is my favorite example was, should you build the cooling tower for cooling the water? And it was such a beautiful, elegant analysis that showed that you shouldn't build it. And the funny thing is that up until this year, I always thought, they were crazy to build that cooling tower. It didn't make any sense. But the thing of it was that they never asked Odum to do that. It was never a question for
Yeah.
that power plant, should we build a cooling tower? They didn't ask that, and I didn't realize that until this January when I was really when I presented this at the Energy conference, and we were talking afterwards, and I realized they never asked him that. He came up with that on his own, and so of course nobody thought that you shouldn't build the cooling tower, even though it was a waste of energy, and the estuarine ecosystem could self-organize with that heat and actually probably have higher metabolism. So that's the thing, is that a lot of his ideas were not, and I always thought that those power plant people were crazy not to accept his analysis, but they were never even listening to it. He just figured that out with Mike Kemp's dissertation, and to me, that's a brilliant example of energy analysis. But it just goes to show that the society can't accept it, even though it's correct from energetics, but it isn't correct for the inertia that society has. And there's some important lessons that all of us who have done Odum's energy analysis will have come up against these kinds of, issues, I think.
Yeah.
Mark's laughing there. He's more.
Well, it's happened to me a lot.
What do you think Odom's response was when, I mean, he came up with those kind of ideas, and we probably could come up with several others while we're sitting here that where people or society rejected his ideas. Do you remember him
Well,
like talking about that, or how he?
Oh, he actually wrote about it in several of his stories, his papers. At near the end of his life, he, sort of acknowledged that he was an outsider, and he saw one of his. I mean, this is something that I've been interested in, and I can track it down in several of the things he wrote. He saw himself as an outsider, and it was his role to try to challenge people with with his thinking. And so I think he really enjoyed coming out with these analyses that were counterintuitive to what society wanted to hear. And that what's interesting to me is it contrasts so much with his brother, who was the ultimate insider, who was really trying to work from the inside and do conservation and stuff. HT was trying to come up with radical ideas to shake people up, and it worked a lot of times just because of the power of his personality, and when you were there and he was giving a talk. I mean, you get caught up in it, but later on you just, it's just not, these ideas aren't acceptable. Like for me, it was, I mean, my personal experience was, you shouldn't knock those boil mounds down. And it was the same thing that he must have felt all the time with his ideas. And that cooling tower to me is just a fantastic example. And I just figured out that that they didn't ask him to do that. And whereas I always thought, up until this January, I thought that was part of the grant, was for him to do that analysis. And it really wasn't at all. He was so creative. He added that on. All they were supposed to do was just measure the metabolism in those discharge canals. It was an ecological project from Crystal River Power Plant. They didn't want him to do the energy analysis. He figured that stuff out on his own, and
he actually
brilliant.
presented it to the company, and they then, when they were trying to convince the courts not to build the cooling tower, they had him testify.
Ah,
He came back from it and he said, good academics can't testify in court because when you tell the truth and it's not what they want to
yeah.
hear, you're a bad witness. And so,
Oh, that's great for me to hear because
yeah.
it does make sense that the power company would want him to say that.
Oh, yeah, it was big, and of course, the environmental community really, he had a black spot then because he was on the side of the power company. And the decision was made, as most decisions are made, on emotion rather than on science. And that was something that he said over and over again many times. But you were talking about the fact that a lot of his stuff was never accepted. He used to say quite frequently, I generate all this stuff and then I'm 20 years ahead of everybody. In 20 years, they all adopt whatever it is that I'm doing and think that, it's cool. And he was always out there way ahead of ecology and of any peer. And it took 20 years, he said, quite frequently before society would pick up on it and go, oh, wow, that's a good idea.
But yeah, and that is actually true. And I think one of the I sometimes want to actually show that with the ecological literature. I think you can actually pin that down for a lot of things. But for other things, he's much farther ahead than 20 years, like this thing about the cooling tower.
Yeah.
I mean, we still wouldn't, we're still building cooling towers. We're still knocking spoil mounds down in these mining landscapes. I mean, so some ideas are way far more than 20 years ahead. I had this interesting thing about I was trying to compare him to because of the importance of the maximum power principle, compare him to like Darwin and Darwin's evolution. Darwin was the ultimate insider. He worked for years and he published all kinds of things to really build the base for proving
Yeah.
evolution by natural selection. And I always thought that HT ought to be on the same level as Darwin, but HT didn't back it up with the kind of layers that Darwin did. I think HT was much more like Leonardo da Vinci, who just came out with these ideas and he filled his notebooks with these ideas that were so far ahead, and he didn't care about whether they got accepted or not in the time. Whereas Darwin was different. Darwin wanted people to accept natural selection, and we should be grateful for it because it was such a hard thing that Darwin overcame. But HT was more, I think he really wasn't like Darwin. He was more like Da Vinci as being so creative and with
Yeah.
with so many ideas. But we've got to get this maximum power principle, I think, credited to him, and so I think that's something that many of us have to try to help before while we still can.
So you were
Since you've been
talking
studying
about,
it,
um,
go ahead, Mark. Go ahead, Mark.
you were talking about his brother being the ultimate insider, and it was quite true. There was a competition a little bit between them. And I remember one weekend, HC and I were leaving the center and he says, well, my brother's coming down this weekend. I said, oh, good. And he says, he's coming down to steal my ideas and go back and make them popular. And it wasn't like the SOB is stealing my ideas. It was like, it takes him to make things that I do acceptable to the rest of the world.
Well, that's the thing was he was such a great communicator. He and it shows up in his books. He figured out how to teach ecology on a general basis in like 1953 with the first edition of his Fundamentals of Ecology. And he never changed that. The interesting thing, he kept writing these books, and the
Yeah.
books never changed. They just
Right.
got updated, but it was always the same thing from 1953 on. And EP wrote a whole bunch of books, but there you can trace all the ideas into that same thing. And so there was never anything new, and it was really, I think, HT, his contribution on energy that was something new between the first and second edition of the
Right.
fundamentals. So I think HT, even though he was 11 years younger than EP, he was it was the roles got reversed in the mid 50s, and before in the early in the 40s and 50s, EP was the leader, was the teacher,
Right.
but and then it switched, and HT became the teacher, and EP was listening after after he really finished off Silver Springs and the uh, the paper with Pinkerton and on maximum power, and so that it's an interesting dynamic that that I don't think people really know, but because there's so few examples of so famous brothers, you
Right.
know,
Yeah.
and in the same field. I don't know of anything, Dave, when I told this to Dave said, "Oh, first thing came out was that Wright brothers, and he's right,
Yeah.
the Wright. So I'm trying to look up the Wright brothers, how they dealt with these brother relationships, but it's just it's really fun to see the interaction between the two in their correspondence.
Yeah.
Do you think that kind of that relationship they had kind of emboldened HT to be even more, aggressive with his ideas since he knew that he could hand them off to EP to make them
No, no,
palatable? Or you don't think that's kind of
no, he was bold and he was brilliant. His thinking was so far ahead of EP's. I mean, EP couldn't, that's the thing. EP couldn't keep up with him after the mid 50s, and EP didn't accept the things that HT was saying. He was a traditional conservationist. I think that some of the things that HT said, which were so out there, I don't think each EP understood or could accept as being correct, because he was very conventional and mainstream and built. He was a builder of institutions, and HT was very different. And I think when you can see it at HT from the big ideas down to the really small ideas. If you read the fine print in his papers, they're just filled with brilliant little ideas. So he was one of those who threw out 100 ideas, and one of them was society would accept. But they're all brilliant, and it's really fun to trace them down. When I was doing the radio ecology history book, I really read the rainforest study, and it's just filled with all kinds of interesting minutia of ecology, which is so interesting because he was completely an aquatic ecologist up until the time he he jumped over into this rainforest, which you know he didn't have any background in, and he just he reveled in it. It was so exciting to him. I think he got energy from the research that he did. It just there was a symbiosis between the ideas. He just raced ahead, and I was talking with Mark about this, trying to figure it out, and Mark wouldn't give me any insight. I think he's held back. But when HT came to Gainesville in '71, he exploded. The ideas just exploded. There were so many ideas when he switched from just being an ecologist to dealing with systems of man and nature. And if you look at the work once he got to Gainesville in the '70s, it's just so explosive how fast he if you look in the 1976 book on energy basis of man and nature, everything is laid out there, and somehow he just exploded these ideas. He had been thinking about them for a long time as he was writing the Environment, Power, and Society. But if you look at Environment, Power, and Society, there's no energy quality in there, really. And so that was a huge deal. He figured out how to do it mathematically, and that was that. I mean, I always thought that was brilliant. To me, the thing that really hooked me was the way in the early '70s, when I was an undergraduate and a graduate student, how he could put dollar values on ecosystems, and then he really elaborated that.
Yeah.
and he figured out how to do it, the math. And I think that's the thing is it's really so simple and easy to do. I think people don't think it can be true because of the way he figured out how to do the energy quality factors, and how to calculate how much embodied energy there is in a in anything. um
I
so
remember the first time he presented the whole idea of transformity. It was on Thursday System Seminar when it was down in Black Hall. And it was, to me, it was quite simple. It was just how much energy it took to make something. That was the quality factor. But I remember, I think it was Walter Boynton walking out of the meeting going, "Did you understand that? That's the craziest thing I've ever heard of. I don't understand at all." And it went from there and became what it is now. Became what it
but
is now.
I think the origin really was in the ecological energetics, in looking at a trophic pyramid. And I think I'm pretty sure that's where it really came from. He really built these trophic pyramids first for Anahuac, then for Silver Springs, um, and then for the rainforest. He did this. He went through the same process, and he did the math to make and the field work to make these pyramids, which showed how energy was transformed as it moved up the pyramid. And to me, I think that was the key to understanding this, was showing it in ecology. And I think that's one of the neat things, as a sort of, I take pride in, as being my own background as an ecologist, that he really used ecology to then come up with these ideas, which now explain the universe. And I think that's an interesting thing. And I think it was really the ecological energetics that started at Anahuac and worked at Silver Springs. Those were the keys that ultimately he figured out. And by the time he got to Gainesville, it all just exploded. There were so many really neat studies that were done then, and so many people were attracted to it at the time. It was exciting. To me, the 70s, because it was all new. And it really, there was something, and I don't understand it. Why was it? And I really think Mark was a catalyst, and somehow that helped this work personally, because there was an explosion in his thinking that took place when he got there. And you can't really track it very much from his previous time in North Carolina. There were little bits of messages there, but somehow he figured out the math, and then he could analyze any system. It was really exciting.
I think probably the South Florida project was a real catalyst. There was money to study the impact of humans in Florida on the whole ecosystem. I mean, theoretically, what he was supposed to do was to bring all of the studies together that had been done, all the ecosystem studies and anthropological studies had been done that were part of the impact analysis for a new jet port they were going to put in the middle of the Everglades. And the Department of the Interior now you would say it's a pittance, and it was $125,000 to sort of synthesize all of that and bring it all together. And of course, as Odum always did, it was he would say, "Well, we'll give them what they paid for, but then we'll also give them a lot more." And it was like the Vietnam project, the same thing. He was supposed to study mangroves. We studied the war. We studied,
Well, that's the thing. I mean, that South Florida, which I think the final report was turned in 75. I have a copy of it. It's about this thick, and it does have contributions from all of the students and other people. Like Walt Boynton has a little chapter on oligohalide systems in there, but it's this thick. And you know who the authors are? HT and Mark Brown. Mark Brown is on the cover of this thing, this
editors,
thick, that
we're the
synthesized
editors.
everything. What were you, like 25 at that time? And he put you,
Was it 76? That would have made me 30.
I mean, you were a co-author on that, and so that's why I think, you know, you're thinking, you know, and you know, it'll be interesting for you to get interviewed. You know, I think you're. I mean, it's like as an architect, you know, you brought something to the table that he didn't have, but he really liked, and but I mean, it's more than that. You're a problem solver, and you know, like you can sail a sailboat over to Bermuda, you know, or something like that. I mean, you got some skills that, you know, I think he didn't have, and so it was a good mix. But something happened when he came to Gainesville that was a fundamental shift in his research,
Yeah, he
and
got a lot of money. He got the
I was
Rockefeller
glad I
Rand
was there
project.
to see it.
And he got the Rockefeller Rand project, which was early 70s. And again, it was a lot of money. That, you know, I think it was really was boiled down to he had money to think. He could support a bunch of students and get things just really stirred up and going. And like he always did, let's see what comes out at the end. You know, let's stir it up. Let's bring a bunch of people together and study the heck out of whatever it is. And, you know,
But you
lots of
know, it's funny to think about how many students he had at once. I mean, he was teaching basically a full load of classes,
yeah.
and he's jet setting around giving talks all over the world. But he's got like 20 graduate students all at once. And as professors, you know how hard it is to do one student. And he juggled all that, and he juggled the budgets. I remember, you know, how could he manage that, you know, that $1 million grant for the Cypress project, you know, while he's piecing together a $10,000 from the, you know, that dredge study that never got done. Actually, he always felt bad about that. I think there were some projects that just didn't get done,
Yeah.
but he was juggling so much. You know, his brain was so busy with so many of these projects, and he's writing books. I mean, he had so many students. I mean, that's the thing. Somehow that you know, there was a feedback that helped, that fueled his thinking. I think so many students, and it was like, you know, I personally never got very much time with him, but it's like I didn't want to. I like just being, because I didn't want to get in trouble. And I just like watching him, you know, from sitting in I can remember sitting in the chairs in the systems ecology class, just enjoying the hell out of it.
Oh yeah.
But he was such a dynamo, doing so many things at once in the 70s, and he did so much with a relatively small amount of money. I mean, you know, the Cypress project was the biggest project he ever had in dollar wise. He
Yeah.
got so much out of a small grant. Sometimes, you know, he got onto some idea that he really liked. He'd work all night, and he'd come in the next day with a model, and, you know, already done, you know, that would take most of us, you know, a month to do. He would have it done overnight and show us, you know, what the idea was.
Well, Betty said he hardly slept at all.
That must have been, yeah.
And he once told me that he made up for sleep by eating.
Well, I remember you were told, if you wanted to meet with him, call him at 9 o'clock. So you call at 9 o'clock, he'd always answer, you know.
Yeah.
I mean, hell, I would never answer a call from a graduate student at 9 a.m., but he would always answer, and, you know, you'd set it up, and you could see him that day. It was always available.
Oh yeah. And those were hard, going to his office or going to did you ever go to his home office?
Never,
Okay.
never.
They
I
were
never even.
they were hard because you're walking into, you know, the most brilliant person that you know, who you think is the almost like godlike, and you're presenting your simply little thing here, and he's passing judgment on it. But
Yeah, that's why I got I got you know, knocked down the first couple times when I did that, but you know, then I figured out how to do it, and it was better.
yeah.
But I was always afraid, you know, and um uh tried. I never had that much personal time. He one time invited me to go to a football game with him,
Really?
and I couldn't at the time. He had football tickets, and he was a big sports fan, and a lot of people had experience with him on the volleyball court. I never
Oh man, he was a
did that.
terror on the
Yeah,
volleyball court. Look out if he was on the front line.
yeah, that's what I heard. Yeah,
He'd really hurt you.
You mentioned a little bit about him in the classroom. I think it'd be kind of curious to understand, like, what classes was he teaching in the 70s? Like, was there a wetland ecology, systems ecology, and like
well,
what was
he
he doing
taught.
kind of special in the classrooms? I know he
I
loved
mean,
like bringing examples and
the
field work and
the systems ecology class was just fantastic, and you can see it from the textbook itself. He would jump from one system to another, and he'd have the energy diagrams there, and there would be simulations in it, and there was details on all kinds of stuff. So that was just such a treat. He also co-taught the meteorology class, which I luckily didn't have to take because it was heavily mathematical. But
It
because
was
I had
hard.
already had meteorology, but I sat in on it anyways, and his stuff was really fun to hear. And then he had estuarine ecology. So those were his three classes when I was there, plus the seminar. And he co-taught the estuarine class, I think, too. But
Maybe with was Clay Montague there when you were
no,
there?
Clay came later.
Okay.
It was some other person. I think maybe I'm wrong. He might not have co-taught it when I was there. He might have taught it just himself then. But that was a fun class too. There were uh, field trips, and there was like one or two field trips, and it was fun to go out on a field trip with him in the field. You get things, there's a crowd of people, so you'd have to fight your way in to get to hear him talk. But and you're out in this salt marsh, and mosquitoes are biting, and you're trying to fight your way in to hear what he's got to say about it. But the field trips were were really really neat too. There was always one in systems ecology going down to Silver Springs, and we'd take the glass bottom boat tour, and he'd be lecturing there while we're all sitting in the glass bottom boat.
And then he'd come back and he would wade
Yeah.
into the spring, stand out there, and all the students are standing on the shore, and he's out waist deep, pulling up the bottom and talking about the benthic ecosystem there. He would do it just for the image, just for the shock value. The student, oh my God, there he is out there.
little bit of a
Same
show,
thing
man.
for swamps, boy. You can't get him anywhere near a swamp. He's in it. Up to his cities.
So no wetland ecology, that came later. He wasn't teaching wetland ecology in the
Did, did, he,
70s.
did he teach wetland
I don't
ecology?
know that he ever taught wetlands ecology.
Yeah, I don't think there was a
Ronnie Best, when he came, he was the one I think that started the wetlands ecology course. But he taught he started the course ecological economics, and then combined it and eventually called it energy analysis. And yeah, and then there were, for a time there was ecological engineering, and then I took over the ecological engineering course at some point. But I think he started it, and then I took it over.
Well, that was after my time. When I was there, it was just systems ecology, estuarine ecology, and meteorology, and then seminars. And so he added more classes.
To me, the system seminar was just that was the delight of the week to be in there. The 2 hours, and he would just come in there. You just never knew when he was going to come in with some wild idea. And like I remember coming in, he'd been working on the stuff with the watersheds with Sylvia Romatelli. Of course, I think Stephen Doherty had done a little bit before that, and he's figured out that the energetics of the mountains are connected to the energetics of the delta, and how it's all this huge land scale connection. And it's just like, whoosh, wow, huge idea. But you must have seen that through the 70s too. Him bringing in.
He come back from he was traveling a lot. and he'd come back from a conference and he'd have some new ideas, and you know, he'd bring them out. It was the mid 70s were an interesting time. That's just when in ecology they discovered disturbance theory. I remember it was like 1977. Connell's paper on coral reefs and rainforest came out, and we talked about it. He came in and talked about it. It was a paradigm shift. Before that, we hadn't integrated disturbance theory into ecology, but he easily assimilated it. But I remember that as being one of the seminar topics. That was a big idea that came out while we were there, and then other people went on to do dissertations on it. John Alexander and John Richardson and others on the pulsing, and he started to get really into pulsing after that, and that became a big deal.
Yeah.
Oh,
Were
so
you there
that's
when-
the
I'm sorry, go ahead.
I was gonna say that's the heritage of the pulsing paradigm is really this disturbance theory, or you think there's evidence thinking about that beforehand with the
Well, I mean,
estuarine
I think
systems?
I think all ecologists thought about disturbances before that time, but we just hadn't figured out how to articulate it. But it was a big paradigm shift. And he I don't know whether I mean, he had been, if you look in his papers, he had talked about pulsing before that, but it wasn't something that he really pushed and made into a big deal until it was sort of after that. So I don't know whether that was a stimulus or not, but I remember in his Texas Bay stuff, he was always into how populations would migrate in and out, and so there would be a big pulse in these estuaries. So he knew about it beforehand, but somehow or another, it became a bigger concept. And I think it'd be interesting to sort of trace all that out.
Yeah.
I never really, I'm still trying to figure out what he was saying about how pulsing, and it's like, it may be that, systems have to pulse, and, so whereas, if you look at all of his early stuff, it was steady states, and that's how we do our model. You use a steady state solution to the equations to solve them. But the pulsing was something new, and it became important. And it may be that all systems have to pulse at some point in time, and so this may be what we see with fossil fuels and our civilization and so forth at another scale. Who knows?
Be careful now.
I'll be our timekeeper. We're a little after 3. I don't know if we can stick around. I can stick around for as long as you want, but I don't know. You guys good to keep going for a while?
Sure.
Yeah.
I'm fine.
Good.
Yeah, I hope you're able to really get a bunch of people to tell their stories, because I think it's going to be really fun. So I really appreciate what you guys are coming up with. And,
So
I know that the audience, like at the Emergy conference, will enjoy this, because
yeah,
when I gave my talk about a little bit of Odum's history, I mean, people really seem to like that. So there's still a sense of Odum's presence in that Emergy conference, and I think that's pretty exciting. I don't know how long that'll last. Like when Mark steps down, which we hope never will happen, but his lead on the Emergy conference has been great. But I felt that a lot of people still were really in tune with Odum in that audience when we were there.
I think so. So you're in Gainesville, you're trying to finish a dissertation, and then you don't finish and you take off. Where did you go?
Oh yeah, I didn't try to finish the dissertation.
Where'd you go?
No, I mean, I wanted to get a job. So I just left, and I didn't have it done, but I liked the fact that I had an excuse to come back then. And so I used to drive down I-75 from Michigan. I got a job at a small college in Michigan and came back frequently. And then once even after I did finish I started a travel study class at this school I was at in Michigan, and I'd take students down to the Everglades, and we'd stop by Gainesville a lot of times. And I know once or twice I stopped by his office, and I annoyed him with having my students there passing through Gainesville. So I mean, I kept coming back for a long time, and then once the Energy Conference started, that was great. You know, we had this um, reunion, and it was very exciting. That the ideas by then were well developed in energy analysis, and that's why I think it's so great that Mark especially has been able to keep that going.
So you were teaching in a little college in Michigan, and what did you, I mean, how did what you had experienced in Gainesville, how did that form or shape what you did at in this little college?
Well, it certainly, I think it got me the job. When I gave this was Eastern Michigan University, which is sort of this mid tier kind of school, MAC conference. Um, I gave uh, my seminar was about energy analysis, and you know, because at that time the ideas were so. This was 1979. The ideas were so exciting about was ecological economics, you know, at a different sort of a different version of it. It was um and it was these were very exciting ideas. So I gave my talk on my dissertation and you know the energy analysis of systems of man and nature, and that's what got me the job. Was people thought that I knew that I knew you know some new thing you know that was going to bring into their
Yeah.
department, which you know I think it was, and so it certainly got me my job. I know some people, you know, it has. I've heard that it works against some people, you know, that energy analysis isn't always valued, but it was in my case, and it got me my job, and I taught um, an energy analysis class for for 10 or 11 years there before I moved to Maryland in 1990. So I taught this stuff, and students loved it at the time. Um, I don't know if that's still the case.
Yeah. So what department were you in?
I was in a traditional biology department.
Traditional biology, and
Yeah.
they hired you for energy analysis?
Well, yeah, they hired me for the energy analysis because this was a, you know, they want to, when you hire somebody, you want to bring in something new. And so, but I had to, what I had to teach the first year was biostatistics, which I really hated and and I did a poor job on it, and freshwater algae phycology. And they, and they wouldn't let me teach those classes again after the first time. I was so bad at it, and so I developed a new class in limnology and in energy analysis, and then these travel study classes. But so they just thought that, and this is what is commonly done. You try to bring something new into a department, and they recognize that as being new. I think the exciting thing was that this was the time when ecological economics was starting out, and that was that was really exciting to me and influenced my master's thesis. And you know, like I said, I the thing that really caught my eye with environment, power, and society in like 1971 was, wow, this guy could put dollar values on ecosystems. Wow. And it made perfect sense how he did it to me, because I understood metabolism. You're just, you know, you figure out the energy flow through the ecosystem, and then you figure out a way to get an energy to dollar ratio, and bingo, there you got it.
Yeah.
That, I just thought that was fantastic. And you know, at the early days of ecological economics were very, I thought, were very exciting. And later I got disillusioned. I mean, I think it went off on a path that wasn't what I was interested in, and
Yeah.
the economists really got a hold of it more, and it turned into a more of a traditional thing, and you ended up with some of these things like ecosystem services and stuff. And I didn't buy into that stuff. But the early days were, like a lot of ideas were being thrown around about ecological economics, and I think it's a great field. I'm really happy that it's been, people have caught on and stuff, but it wasn't for me after the beginning part. But that's what hooked me, was how
Yeah.
Odum figured out how to put a dollar value, which was early, was in the late '60s, and in Environment, Power, and Society. That was pretty exciting, I thought.
And you trace it back to one of his studies in Texas
Yeah,
with the bays, right? With
yeah,
taking the price of straw or hay or
yeah,
something, right?
yeah, yeah. He could figure out how to do, an algorithm for calculating something, and to me it made perfect sense. But like, to economists, they thought, well, this is, this isn't right. They find plenty of reasons to criticize it. But to me, as an ecologist, coming from sort of the bottom up, which is the way he thought about things, he learned them. I think he figured them out in ecology, and then he took them to the bigger scale. It made perfect sense to me. But
Yeah.
and but society, it's just not done that way. Ecological economics didn't work out that way. So, um, but they're doing great things, I guess. So
So we'll continue on your academic trajectory. So you're at Eastern Michigan through the 80s, and then in 1990 you come to Maryland. Is that right?
yeah,
What was the decision
and that,
there, and what was going on? And
yeah, that's the thing too. I got into. I mean, it was modeling. It was Odum's energy modeling that got me the job here, I think, because my interview seminar at Maryland, I showed some simulations of tropical deforestation. I got involved in that, and some controversy, and but that was still Odum too that got me this job too, because it was his simulation modeling that really worked the trick there. By that time, I had, you know ecological economics had moved way beyond what my work was doing. By that time, they were well into a lot of more traditional kinds of ways of valuing nature. But the simulation stuff was still important then, and we were in this big crisis about worrying about mass extinctions in the tropics, and I had some things that weren't always favorably looked upon, but say about that. But I had it was that modeling that got me this job. And I think that the controversy, too, I mean, I think that helped me get the job. I mean, but it convinced the people. I was able to convince the people. And so again, it was Odum. And I think he wrote letters for me to get this job here too. So, I mean, I don't think I could have got it without his help.
so what was the attraction for Maryland? Did you know some people that were already here, or there's something going on here that you really wanted to be a part of, or?
Well, I wanted to get out of the small school and get into the research tier. And so it was an opportunity to really move up. I ended up taking it was kind of a part administration job. I had to run an undergraduate program here, so they needed somebody to run this natural resource management program, and I had done some um, stuff that dealing with a lot of undergraduates at EMU that showed that I could work with the undergraduates here. So they wanted somebody that could do that, and sort of energize this undergraduate program in sort of environmental science that again, the ideas of systems ecology were viewed as being sort of new, cutting edge at that time in 1990. I think things have changed a bit. Things have evolved, and that's why I think it's going to be fun to see you guys interview people at different ages. Like, I mean, Dave's story, I think, is going to be very interesting, much different. I mean, I think you were at Gainesville in the '90s, right?
Came in 94. Yeah.
And so it'll be interesting to hear your story and stories from your generation. And I know there's a whole bunch of interesting people from your generation. I mean, it's fun, that the 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 students that are in the same classes with you are like the best, your best friends for life, I think. So like the people that were in my classes at Gainesville, I mean, I value them as some of my best friends. I was basically the class right after Mark. And so we looked up to guys like Mark and Bill Mitch and Mike Kemp. But I was there with Dan Campbell and Dennis Sweeney and John Richardson but we got some mentoring from people like Mark and Tom Fontaine was big in he helped me mentor. Mike Kemp wasn't much of a help. When I first went down there, he had just defended his thesis and I happened to be going into Odum's office while he was coming out, and he stopped me in the hallway and said, "Don't believe anything this guy says." That was a shock to me. I mean, I was really looking up to Odum and everything. And Mike was he had sort of foul moods every once in a while, but I mean, he really treasured Odum. But I mean, at that moment in time, they didn't get along too well, I think, in his dissertation defense, and so Mike, that was part of also the reason why I was afraid of Odum. I had these
That's kind of par for the course, though, for an advisor and advisee to kind of butt heads around finishing the dissertation. It's just a lot of
well,
emotion.
Odum was very kind to me at the end. He helped me a lot get through my defense, and I remember I didn't take differential equations, which was a requirement, and he helped me talk my way out of that to get out of that. Now I had the chairman on my committee too, Ed Pyatt at the time, and so that might have helped. But so Odum was very kind to me as I was going out the door. But I was scared to death of him coming in. I mean, and just was very much in awe of him, and to see the way he managed that system in the mid 70s, the Center for Wetlands, all these grants, all the jet setting he did, all the books he was writing, and I mean, he was a dynamo.
I was going to bring you back to your time when you got to Maryland, or even your time in Eastern Michigan in the teaching. Like, what were the students finding really exciting about the systems ecology, you think, through all those periods? Was it evolving, just changing from year to year, or like what were the students really attracted to from the systems ecology?
I mean, I was teaching this energy analysis. It was called energy analysis and environmental decision making through the 80s, and the students loved it. It was an undergraduate class, and they just loved this idea about how you could use this energy math to come up with these analyses that put values on nature and could help you make decisions. They just loved that. The systems ecology class that I taught at Eastern Michigan was at the graduate level, so there was only 6 to 8 students in that, and these were not real hotshot math students. So it wasn't as popular, but the students really were in tune with energy analysis. I feel like I was able to teach the energy circuit language and get the ideas across about the energy math algebra, and they loved it at the time. And I think that's Mark's experience too, don't you think? I mean, I've seen a lot of your students that thought very highly about the energy analysis approach that you were teaching, which I think was Odum's approach. So
yeah. Oh yeah, it was very well. I taught systems ecology, and then I also taught, of course, it had energy analysis in it, and my courses were real popular. I had lots and lots of students from all over, and it wasn't because they were easy. I mean, it was because they were fun. I used to look at it. The first class I went to with Odum teaching, I said to myself when I walked out, now I understand where all of the stupid courses I've been taking fit in the grand scheme of things. I've taken chemistry, I was taking physics, and I was, taking all these math courses as part of the architecture program, and they were all separate. And one course with him, one lecture with him, and I thought, "Oh, now I see it all fits together." That was the end of me. I switched fields, and and it was just because he, in any lecture with him, there was always some chemistry, there was always some physics, there was some economics. It was all, thrown in at the same time, and it was so much fun.
Well, I think all of his teaching and his lecturing involved the energy circuit language, and I think some people are attuned to that, and some people aren't, and so it all depends. And I think the people that were attracted to him, obviously, were attuned with this symbolic modeling language.
Yeah, yeah.
But it's my experience that there's another type of thinker that just can't relate to that at all, and they see these as being too complicated to communicate. And so I think there's at least two kinds of people in terms of these models. And then of course when you get into simulating, I mean, math of course is another
Yeah.
divide. And so this isn't going to appeal to everybody, but to a certain group it just clicks and makes sense. And I think it's from our own experiences as teachers, um it wasn't just because it was Odum doing it. We were able to communicate these things, and I think it was popular with the students. And I know Dave has had the same experience too with students, although I don't know, he's got it to say whether it worked or not. But I mean, my students really, they really liked it. And I think if I was still teaching it, I could still get those ideas across. Dave, what was your experience? Because
Yeah,
you
I think
taught.
yeah, I mean, definitely it clicks with a certain type of student, but then other students, would really struggle with the math and just the connectivity that you see in the diagrams. But then you had the students who just really loved it. I remember I once had a student, I taught them the energy analysis course, and then I was walking through the parking lot next to our building a few months later, and there was a license plate, a vanity license plate that said Emergy. And I thought, who has an Emergy license plate? What is this about? Somebody visiting? Has Pat gotten an Emergy plate for his car? And no, it was a student that had my class. I had no idea that they were so into the concept, but they thought so much of it that they used that as their vanity plate.
Wow, that's a great story.
So there's that extreme, but then of course there's the other extreme as well. So it's a mixed bag, but it's always been my bread and butter. I think it's just such a powerful way to see the world, and that's what you really want them. I teach it to them as a lens to a different way to see the world, so trying to get that point across to them. They seem to appreciate that for the most part. Well,
Are we at a jumping off point?
what's that, Mark? Sorry.
I said, are we at a jumping off point here?
That's 1.5 hours. A lot of material there for sure. This has been lovely, Pat. I knew it would be. So I really appreciate you being the guinea pig. I think our next steps, we'll go back. We'll probably do a little bit of editing. Probably put some stuff on the front end just to introduce the podcast, all that kind of stuff. Mark and I can do that after the fact. But yeah, I'm excited to get this going. I had the idea a while back, and I told it to some other people. Like, oh yeah, that'd be a great idea. And then when I was visiting Mark a couple of months ago, I shared it with him, and of course he jumped right on the idea and it's like, oh yeah, this would be something we can do. And
it'd be so cool.
so this is it. So I'm excited to talk to these other people. You're talking about a lot of people to me are just they're Florida famous to me, Center for Wetlands famous. I know these names, but a lot of them I've never met. So I'm excited to do this with all these folks. So, but it's great to start with you, Pat, because I've known you for a long time now, and worked closely with you. So appreciate it.
Well, I appreciate it. I think this is a great thing you guys are doing, and I hope you reach out to these ladies and gentlemen here. And I look forward to seeing future podcasts. I'll have to, start looking to podcasts.
Yeah.
Well, the idea is
Just like watching TV.
we're gonna use this as bait to capture anybody else. Anybody else that has a question about what we're doing, we're gonna show them this as our example potentially. So
Well, I know that Charlie Hall would be a good one. He's very enthusiastic. He's really, I mean, what he's doing with this Biophysical Economics Institute is pretty credible. He's not really, he's a little bit standoffish on energy quality a little bit. It came after his time, but he
Yeah.
likes, he buys into the Odum stuff, but he's got such great stories and he's doing such great stuff with energy. And I think he's co-authoring this book on maximum power, so he'd be a great one for you guys to hit up.
Yeah, I'll
And
talk to him soon. We were just gonna do you sit back and then make a list of people and then start contacting them and seeing how many of
yeah,
them are willing to do it.
I knew I kind of was feeling out Walt Point, and I just was in a committee meeting with him, and he'd be great too. So you guys know the list, so it's going to be great, and I think the sooner the better because we're dying off here.
I know.
But some of the young people, it'll be great too. I'd love to see some of the young people and some of the people that have got it that didn't have direct exposure to HT too.
Yeah,
And of course, maybe, I don't know what your plan is, but I mean, I certainly would like to learn more about Odum's legacy and how it's being how it's emerging as time goes on here.
okay. Well,
All right,
thanks.
so you'll come get this computer, Dave?
yeah,
Okay.
we'll wrap up here and I'll be right over.
All right.
All right.
All right,
right,
take
Mark.
care, guys.
Thanks a lot.
Yep.
Dave, we'll be in touch.
Yes.